my name is Temitope Omolere. I work with InduSwitch and I lead the quality assurance team there. And so the goal of this conversation is just for us to interact and give developers an idea of how to write code from a quality perspective so that your reputation and even your own confidence also is solid in terms of the work you churn out and the work you deliver, the quality of work you deliver basically. So I'll just jump right into it and I started out my career as a software developer, so this is not new to me. That's my foundation basically before I ended up in quality assurance. I'm very curious, and so I ask questions a lot, and I love when systems work. And that is the driving force for what I do primarily. And I love collaboration. So for me, it's always a joy because even the craft of software development involves collaborating and working with several people in order to get the results we want. And so with that in mind, I'm just going to jump right in and pretty much what I'm going to try to do here today is to just give us a mind shift of some kind, trying to help us see from a different perspective the software development craft. It is a known thing today that whether or not we like it, there's this unspoken war between quality assurance people or testers and developers about the fact that, it's working on my bugs, it's not working, you're just being funny, you're trying to look for trouble, you're witch hunting me, you're making my life difficult, that is why you're looking for all the issues in my solution, and then you're going to go and report me to the boss to say I didn't do the work well when you should have just engaged me in the background. Like, why is all of that happening? So today I'm just going to be trying to speak with us and hopefully help us see a different perspective to how we approach code. Bear in mind that I'm an ally because I started out my career as a software developer. So for me, when I am testing, it is not just from a place of I'm trying to make you look bad. It's from a place of we're trying to make this solution work and give value to our customer. So that's the first thing I would start with, and then I'll just jump right into it. The first thing I want us to understand is that at its core, software development is half of your skills and half of your mindset. You could be a very good software developer, but if your mindset is let's just drop something, let's just write the code, let it just work, without paying attention to some of the underlying details, eventually the cracks will show. It's only a matter of time. So with that in mind, one of the things I always say is that what sets apart the senseis from the initiates, senseis mean the gurus, and the initiates mean, of course, the fresh people who are just starting to enter into software development, is really the true quality of their engineering. It's about how good and how well do you write the code you write. I always refer to a colleague I had in the early days of my career he had a knack for writing. He could use 3 lines of code to achieve some really profound functionality, and I'll be like, how do you sit down to craft code in a way that, like when you're reading code and you're actually enjoying what you're reading, because it's simple, it is precise, it is concise. That is true engineering, because you're able to succinctly express yourself in code without being too verbose, writing 10 lines of code to do something that can happen in 3 lines, and doing it with code that is actually performant and responsive at the same time. So I say that the high value developer delivers scalable code that is understandable by other software developers and engineers, and that works in every given scenario. Because basically it is saying that you are so confident in what you've done, and what you've done is of such a high quality that either ways, at any point in time when anybody needs it to respond, basically when it's called upon, it responds because it does what it should do per time. And the first thing I want us to shift our mind from is the fact that when the tester tests, they didn't put the bug there; it was already existing there. So when we're testing our code as developers, when we're writing the code we write as developers, bear in mind that that bug was already there. The only thing that the testing process did was just to review what was already in there. So when you come with that mindset to approach when you're writing code, it helps you shift from feeling like, somebody is witch hunting me. It just shows, that means there's an oversight. Probably there's something I do not yet understand that I need to now pay attention to. Perhaps there's a concept that I did not know about that I'm now aware of. Basically, it's making you aware of the things you were unaware of before. Because nobody starts out writing code with the intent to actually make it buggy. We all write code with the intent that, I want this thing to work and to deliver value, and I want to get it done in the best possible time, shortest possible time, reasonably, and saving cost and all of that. So with that mindset in mind, I want us to leave here today remembering that anytime somebody is testing, even if it's you testing your code or looking at your colleague's code and you find something that is not working, the person who is getting the feedback should remember that it was there already. Nobody put it there. It was what I wrote that is being revealed. It's just that it has now been passed through. It's like saying that when you have broken bones, it might not be immediately obvious that your bone is broken, but when you go through the x-ray, The X-ray will show where the broken bones are, and then you can tell, oh, this bone here is broken, this one is broken. That X-ray didn't put the broken bone there; it was there already. So this is very key that we live here today knowing that testing doesn't break apps. It only reveals what was already broken, and it helps us. Then helps us to fix the problem that we have now revealed. So like I've said, it's only you as a developer that can do anything about changing your approach to quality. When you have found a bug, the bug was already there. So it's now up to you to make a change, to fix it, to figure out why it got there, why it's behaving that way, and hopefully get rid of it. The next thing that I want us to bear in mind when we're approaching testing is that testing actually provides immunity for your software application. And to put context to that, it is basically a way of making sure that, see, this thing is foolproof, it is safe, it is secure. There is nothing that is going to happen that I did not already anticipate and take care of. So when you're testing, or when somebody is testing your code, when you have that mindset that this is what it's going to do, this is basically giving me immunity, this is basically giving me my vaccine to ensure that I am able to face whatever COVID or whatever flu is out there, and I'm not going to run into trouble because I am defended. That is what testing does for you. And there are different types of testing, which I would bother going into it today because really that's not the scope of this conversation. But it's just to let you understand that when you understand that testing, that is what it does to your code. For you as a developer, when you're testing your code, and even for your colleague who might be a QA person testing your code, it gives you a different mindset. So you no longer have to feel guilty or feel bad that, oh, this person tested my code, now they are making me look bad. No. It builds your confidence in realizing that we're allies. This person is working for me and I'm working for them. By them checking this in and finding this problem now, then I'm not going to look stupid when we get to production and this thing starts going down. If you work in the banking or in the financial industry like I do, those kind of mistakes literally cost naira and kobo. It costs real money that potentially can bankrupt a company. I don't need to say too much. We all know about eNaira when eNaira first launched. We all know about MTN Mobile Money when Mobile Money launched, the kind of fraud that went through it. And that was because somebody somewhere didn't check something. Or maybe, I don't know what really went wrong specifically. But the point is that those solutions did not have the necessary defense they needed because somebody did not test, or the testing approach was not proper. So when you understand as a developer that by testing, it is the humility my code needs to confidently go into the world and do what it has been set up to do. It changes your mindset. It changes the way you approach your code and even your colleagues who are doing the work as well. It infuses within you the confidence that your code will not disappoint you when you need it the most, because then you're sure. So I'm going to tell us here today that you should eagerly welcome test feedbacks as well as retrospectives when you are reviewing your code, because it helps you identify your blind spots and it also improves your area of weaknesses, because in those contexts, now that you've seen where the challenges are, you then can tell, oh, this is what I need to do, this is how I need to change it in order to make things better, and in order to then deliver code that is responding and doing what we originally wanted it to do. So we test to learn more about an application so that our end users can have a positive experience with it. When you're testing, the goal is so that I know how my code is going to be when it gets to production. I'm not afraid. A phrase I use a lot is I want to deploy and go to bed. I don't want to deploy and then be on the edge of my seat waiting to hear that there's a problem or waiting to hear that something went wrong. But when you've tested by yourself, when you've written quality code within your power, and then you've collaborated with your colleagues as well to ensure that that code actually behaves the way it should, you go to bed and you're not afraid. Again, I'll reference because there are many mission critical systems today, particularly in the healthcare. There is a particular solution that I did not reference here, but basically it was a radiology solution in the US where, because of flaws in the system, it was releasing 10 times, or was it 100 times more radiation into the people that it was x-raying. That was basically death. People died from it. That is the impact we have as developers when we write code. When there is this, the Airbus I forgot the exact number now, was it A750 or something, when it was crashing everywhere, it was software glitch. It shows you the kind of power we have as engineers. And so when you understand that, there is a Jeep in the US, there's this Jeep vehicle. One of the vehicles they make is the Wrangler, another one is the Rubicon. It is known that there was a glitch at some point in that car that people could remotely take over the car and drive it off the road. So imagine you're driving your car, and somebody is able to remotely take over the control of your car and drive you off the road and wreck you. That's the kind of power we have. But those things are possible because the code was buggy and somebody did not check. And maybe the person writing the code consciously, unconsciously, mistakenly, oversight, with all the best intentions in the world, somehow did not catch that problem. So when we understand how critical the things we're doing is, we begin to understand why we need to pay attention to quality. It's not because somebody wants to stress you. It is not stressful to have quality code. It is actually your badge of your street cred, that you are your code is of good quality. Like I referenced somebody here today who I said his code, every time I'm testing anything he wrote, I was happy to do so because it was very precise, it was very clear. And it was that thing of where you're getting when you're finding bugs, you're finding real bugs. You're not finding flippant issues like somebody didn't handle an error and I'm seeing stack trace inside the browser. So those kind of things. So again, to emphasize, just to close out this, testing really just gives your code immunity. It's the badge of is the certification to say that this thing works the way it should, and so we should not be afraid of testing, even as developers. The next thing I would say is that testing is the software development equivalent of talking stage when you slide into your crush's DM. We all know everybody slides into DMs these days, it's normal, right? And so basically it is saying that you're getting to know your software, you're interacting with it. You've written it, you've met this software because now it's no longer in your mind, it's now physically on a server. Now you're interacting with it, you're asking it questions. You're asking, how would you behave when I do this to you? When I put this kind of inputs that is not supposed to be acceptable, how would you respond to me? When you're understanding what makes your software angry, what would make it throw exceptions, what would make it throw errors, what would make it crash, what would make it become slow, what are the things you would do what are the inputs you would put that immediately everything will crash, those kind of things. That is what you're doing when you're testing, really. You're literally getting intimate with your software, you're understanding it, you're knowing its idiosyncrasies, such that when somebody who is new then asks you, how does this thing behave, without you even going to go and let me remember, because you've walked around it, you've played with it, you've done all kinds of things with it. Basically, you're sure of what it does. You're confident about the way it behaves now. So embrace your tests with that kind of zeal and ginger. The way that when you meet somebody new and you're chatting with them constantly, you're sending them DMs, you guys are trying to plan hangouts. That is what you should do with your testing when you're testing your code. And I'm not even saying this from the perspective of somebody who is the one testing, third-party testing. From you who is writing the code, get to know that solution you're writing yourself, Ask what can it do. Explore how it behaves. What makes your code happy? What makes your code angry? What is constant? Does it behave the way it should behave in every situation? Or does it begin to shake after a while? Does it abandon you when SAPA starts, Does your code respond every time? Every time, does it answer you when you call? Like, is it reliable enough that you are sure that? Because we all look out for friends that we're saying that this is the person I know that if anything is happening in the world, if I call this person, they'll come through for me. Can your code come through for you like that? Like, can you confidently say that the code I have written will come through for me like that? That if they say, let's do a demo now, you're not afraid that, my developer should not see, or my boss should not see this because it's not ready. Those are the things that so when you understand your code from that perspective, it changes how you are testing your code yourself, even before you pass it on to the next person that is going to do the QA on it. The next thing is that I want us to remember that software is created to be used for a specific purpose. If it does not work well or correctly, it's not serving its purpose. So there's no point doing all that hard work. And then when it gets to where it should really deliver, it's found wanting. Then people's lives are, at risk. People's money is at risk. Your integrity is at risk. Even you are no longer confident, and then you start having imposter syndrome. You're asking yourself, do I really know this work? Was it a mistake that I took this job? Should I be looking for a different career? Because that day will generally, even as developers, standard, it will come when you're asking yourself, why am I doing this? Because you're debugging and it's not working. You're implementing a feature and it's just not looking the way it should look. So that is bad enough. But when you now have to then deal with it because you are not even putting in the effort to make it good, that makes it even worse. Because you then start asking, when they test and they come back and they list like 10 million errors, you're like, I have a colleague here who seems to be doing fine. And then it's me that every time they test and come back, they have a long list of things I need to go and fix. Now only me waka come, like, who did I offend, But when you approach your testing and your software in the context of that, it needs to do what it needs to do, and then you're putting in the effort to make it do those things, your confidence rises. Literally, they tell you to come, you say that, let's go. They say your software is behaving a certain way. You say that, no, I know it cannot behave that way because you know what you've done, you know what you've put into, you know how you've checked it, you know how you've literally tested it and flogged it in every direction, and that gives you the confidence. And whether we admit it or not, many of us still find validation from the quality of the work we do, from the confidence we have in our jobs. It's why we describe ourselves and say, I am a software developer, I am a quality assurance person, I'm a DevOps engineer, because we are confident in those skills we have. So imagine that thing that you now build your confidence on itself, in your heart of hearts that is shaky. and you cannot boldly show up and say this is what I do because you're not very confident in that. So that is the perception I want us to bring into when we say testing your software. This is not testing your software because somebody else is doing it. I'm talking about you as the person writing that code, testing it yourself to make sure that you can confidently say anywhere they call me, I can defend this thing I wrote. You know. So having listed all of those, I'm just going to run us through a few action points that we can take as developers to help our development experience. The first one is this: get curious. And when I say get curious, is that ask questions. What's this thing supposed to do? Is it doing it? At what point does it stop doing it? What are the things that happen when it stops doing it? What are the things that are okay even if it happens when it stops doing it? What are the things that if they happen with this my software, we're in trouble, the world will end? What are the things that if they happen, well, we can still recover? And then how do we make that recovery as fast and as quickly? Those are the questions you ask for every line of code you're writing. The next thing is that you take responsibility. Don't wait for someone to say, don't wait to say, I've written the code, I've passed it on to the next person in the delivery line to check it and tell me if anything is wrong. Take responsibility. Tell yourself that because of the kind of developer I want to be, these are the things I'm going to do. And that is to, in this context, adopt a coding standard. By having a coding standard, it literally just saves you the thought process of, I'm thinking of how to make this thing happen. Because the standard is very well defined. In fact, most of these things you can actually get on the internet. So once you're able to pick a coding standard that works for the particular framework or the language you're using, it gives you less inertia and brain power. You don't need to apply more brain power to figure out how do I make this thing work, because the coding standard by itself will guide you. More often than not, some of these things can even be installed in your IDE, such that because they are there, when you write something that is going to leak memory, it will tell you that this code here is going to probably leak memory. You will write some code and it will tell you that this code would not be reachable, because the way the code is currently set up, there is no execution that would enter this particular block of code you've written. So maybe you should not bother, or you should refactor that area. It might even tell you, even initially you might have written the code and it's fine, and then one day it will flag an error and tell you something like, oh, this particular method you're using is about to be depreciated, so you need to update it and maybe take a new pick a new version of that SDK so that you can get a newer and more performant version. So just by simply doing that alone, you've upped the game in terms of how your software works, because now you are steps ahead of the person who is using their mind to think of how to make it performant. The other thing is TDD, that's test-driven development. That's basically saying that as tedious and as boring and as annoying as it seems, the truth is when you adopt test-driven development, it's your what's the word now? I'm trying to find the word, but basically it is that thing that saves you before you even run into trouble. It's your first line of defense. Because before you wrote the code, you've already told it that this is, when I test it, this is what it should do, this is how it should respond. So that as soon as you're done writing that code, when it doesn't behave that way because your tests are not passing that you wrote yourself, you already know there's a problem here, I need to go and fix it. So test-driven development is basically saying that when I submit this form, it should show me this message. So you've already looked in that your test and said, when this page will see this message. Now, when you come the first time and that message doesn't show, you already know there's a problem here because my user has said that the response they want to see is XYZ. But right now I'm seeing ABC, so there's a problem here. I need to go back and check what I'm doing to fix it. By the time you've written all of those tests and then you write the code that matches and solves those and that makes those tests pass, you are more confident in what you've done. So again, Rome was not built in a day. So those are the things you begin to do that gives you more confidence in the output you're putting out. Also, behavior-driven development in its own case is from the context of how is this solution supposed to behave in terms of how will my users use it. As a user, maybe as a bank account holder, I want to be able to transfer money from my account to a customer in a different bank. That is the behavior that you want to see. When you've written your tests in a way that demonstrates that behavior, what it does for you is that it gives you opportunity to then see how your users will interact, and you kind of programmatically walk through that path with them to see the way it will also respond. Because it's easy for us to write code and be like, logically, based on what I've written, this would work and this is how it would behave. But when you exercise that code, you realize that, oh, it's actually not behaving that way due to something that you did not see or did not anticipate. So by using a BDD and TDD, they just have a way of pre-protecting you from whatever is to come when you eventually write the code. The next one I would take that I would look at is embrace technology. See, life is not supposed to be hard. We could have been here today without microphones, without headphones. Then we'll both be I'll be shouting for you to hear me. Then you would not hear me because there's a noise coming from the other side, and you'll just be frustrated. So the fact that we're even able to hear each other here today is because of technology. That is why we have the headphones and the microphone, and we are engaging. The same thing for your code. There are technologies you can adopt to make it simple. There are tools you can install on your laptop that would immediately scan your code and tell you, oh, there's a security challenge here. I don't know how many of us are aware, for instance, with the top 10 OWASP OWASP, anyway, I'm not going to try and remember the full details now. But basically, OWASP is that what they do is that every year they will list the top 10 vulnerabilities or issues that people typically encounter in the year before, and then encourage developers to work around making sure that those things are not replicated in their code. Now, it's a standard, it exists in the world. Things like cross-site scripting, things like DB, SQL injection, all of those things are part of what is always on that list. By having a tool that is by itself, out of the box, monitoring those things for you, you don't have to worry about it, because as soon as you write a code that would encourage SQL injection, that thing will flag it and tell you there's a problem here, sir, stop here, or there's an issue here, man, you need to fix this problem so that you don't expose yourself to this vulnerability or this problem. So that is what like a static code analyzer does. They scan your code as you've written them and tell you this is where the problem might be. This thing you're doing here, you have a memory leakage here, or this code block you've written. There's nothing in how you've run this code that this block would get executed. It will tell you things like the way you are using this particular method is going to cause a memory overflow. All of those things will come out in those kind of static analyzers because they know what to do. And so you don't have to worry about those parts. So adopt those tools. Then there is also the part of you lowering your defenses. We are naturally defensive. If you come and tell me that the thing I have created does not work well, hello, do you know what I put into this thing? Do you know the time and effort I put? How can you come and face me and tell me it didn't work? But sometimes we need to be humble and just say, okay, let me hear what you have to say first, and then be sure that truly it's valid or not. Where it's not valid, have a conversation. Where it's valid, take feedback, and then move on with it. And so in that context, what we do is welcome feedback. Allow people, be approachable, that your team members can come and tell you that I checked your code and this might be a problem. I think you should look into it. And then you're able to say, okay, thank you, I'll go and check it. Half the time, the challenge between developers and testers is always between the fact that how dare you come and tell me that what I wrote is not working. I tested it, it's working on my box. But perhaps, just perhaps, it does not work. It's not working on the server in the test environment. Or maybe it's even working on the server and it got to production and it's not working. And truly we went to check on the test environment, it is fine, but it's not working in production. So, but if we are open to feedback, it helps us able to quickly respond to problems. Because while you're arguing that it's working, it's not working. Production is causing problems. People are losing money. Lives are, getting lost. But when you are open to feedback, as soon as there's a problem and you're able to, okay, let's look at it together and confirm that it's really a problem or not. It solves the problem quickly. So be open to feedback and then build allyship. We do not have to be enemies. And one of the things I've learned is that you would never know everything. I would never know everything. But one of the, like I mentioned at the beginning, one of my super strengths is collaboration. So I tell people that, see, it's okay not to know. What is not okay is for you not to know and then pretend like you do and then cause problem for everybody else. So it's okay not to know, and then you go and meet the guy that sits next to you. Guy, this thing I'm struggling with it, I don't know what to do with it. Can you tell me what you've done? Or have you encountered this problem before? It is as simple as saying to your, if you have a tester that works with you, to say, I noticed that when you test, you always come up with these errors. Tell me how you do it. What do you check when you're testing? And then they too will likely ask you, this automation, this thing you wrote, I'm trying to automate this area of my code. Can you show me how to write that code to automate this aspect of my test? What it has done is that you guys now are collaborating. You are now together. You're working with each other together to get results. Nobody knows the difference when at the end of the day the solution works. Everybody's like, the team did well. But you all know that because you have borrowed and leveraged somebody else's strengths, now you are able to get the power of two as one. You're synergizing. So that is where collaborating cross-functionally comes across. Don't just sit within your own bucket of what you know. Talk to people in other fields, the DevOps person, the SRE person, the QA person. Have an idea of what they are doing so that it helps you also do better. And finally, I just mentioned a few tests that we can look at, some kind of tests that on the developer level. Nobody is going to ask the developer to test everything end to end, but there are some basic checks you can do by yourself that will just give more confidence to the code you've written. So one of them is unit tests, which helps you to detect error early, because as soon as you write your unit test, certain functionalities that behave right or wrong will become apparent to you immediately and you can fix them immediately. The other one is integration tests, which just pretty much talks about how components work. Today, one of the core of software development is integration. If you're not integrating to an SDK, you're integrating somebody's API, somebody's endpoint, you're always integrating anyway. So integration tests also help you see how systems behave when they cross from one domain to the other, or when you're like the handovers and the handshakes, how is it, how intimate and how concise and how accurate are those handshakes. Then finally, regression tests. I tell people that one of the most the best hidden secrets for developers that they do not have harness is regression tests, particularly in a development shop where you have QAs that write tests. Your regression test is basically that thing that you use when you finish writing your code. You ask your QA for the test that they used previously for the last time you deployed this code and say, bring it, give me. And you run it against the new things you've written. Regression test will immediately tell you if what you just introduced has caused problem. It will even put you on blast at all if you run it yourself. It becomes a problem when you tell your team members that have finished, the QA team can take it, then they take it and then they go and run regression and then everything is red. So suddenly it's like, did you erase the code that was there before and just introduce all kinds of things? But when you take the regression test before they even get it, literally you build it into your development time to say, okay, when I finish writing my code, I'll try and finish writing my features like maybe a day or two early so that I can run the regression test against it in my own environment and see how it is responding. If there's a problem at that point, you can fix it immediately, quietly. Nobody's even any wiser that anything happened. So that is where regression test comes in. You don't even have to be the one that wrote the test, but you can run it against what you have to prove your work and be sure that, if you are writing an essay, you'll be proofreading. So that's you proofreading your code to make sure that it is behaving the way it should before it gets to the world people and then they start, raising bugs and raising tickets against you. So having established that, I'm just going to show, I just listed a few developer friendly testing tools here. I know one of the biggest annoyances for developers and even QA people is the fact that why do I have to do this thing repeatedly 10 different times? I'm testing login, so I have to type username, type password, maybe even type OTP 10 times because I want to test this thing. But when you have automation in your testing pipeline, when you've introduced automation to your testing, it blows it out exponentially. Basically, it just liberates you in many ways. And so these are some of the tools that I feel like, because again, developers don't like stress, but you're familiar with code. You'll be happy to write code, but when they say come and start clicking through UI, it's war. So these tools would help you. So the first one I listed is API testing. I think maybe I'm biased. The shop I work in today, we do loads of API more than UI, and I think that is really where the world is. Almost everybody is more API focused than UI. So if you don't see anything really speaking too much to UI, it's because I don't do a lot of it. Postman is very simple, very basic. It does all the basic checks for you effortlessly. In fact, you can write tests inside Postman. You can write JavaScript inside Postman. You can write code snippets inside Postman to assert the values, to confirm that the value you're expecting is what came back. And you can even extract a value and pass it to the next call, literally to run a user story or a user flow. So Postman, as simple as it looks, is a very powerful tool you can use to just do your basic initial tests. The other strength that Postman gives you is the fact that today I know that in almost every software development shop, the challenge is you tell the QA API is ready. They will probably ask you, so where's the collection? Where are the endpoints? And where are the data that should go into that endpoint? By creating a Postman collection, when you're writing your code, you've answered that question immediately. Because as soon as you finish writing your code and then you go to Postman, call your endpoints, put all the values, all the fields and the values you're expecting, immediately you've answered the question of where's the collection, and it's already part of your development flow. So you've literally set yourself apart for your QA to say that, oh, this guy is the one I want to work with because he always comes correct. Everything I need, he comes ready with it. He front loads it to me, so I don't need to go and then beg him and fight about it before I get it from him. So that's for Postman. Performance testing, JMeter DSL. I imagine most of us are familiar with JMeter. And JMeter today is just UI based, it's Java based. In fact, the UI of JMeter is from, I don't know which edition of Java, maybe Java EE, eons ago, and it's so ugly and very unfriendly and very boring. But with JMeter DSL, it's a Java-based API for running performance tests. So basically, so it removes all the abstraction of dealing with UI, dragging and dropping. Just go straight, use APIs to configure the performance test you want to do and run your tests. So then the other one is Jest for JavaScript testing framework. Because one of the big languages today, many people are writing on JavaScript-based frameworks for their development and UI. And so Jest is one of the key tools that you can use to test in JavaScript. I know it works for Angular. I know that Facebook, I think even Node.js as well. And I know Facebook actually was the original creator of Jest, but they've open sourced it now, so there's a different part that is open source. Then for those who still do browser-based automation, Cypress.io works. And it works on UI level, so you don't ever even have to open a browser window if you don't want to. You can open your browser, you don't have to click rather if you don't want to. With Cypress, you can literally run your tests, interact with your web pages, and even APIs too from Cypress, because it will allow you to create a browser object, do all the load the page, enter the username and password, whatever fields you're filling, submit a form, assert the values on the form, all from code without you having to deal with all the boring parts of clicking through or even record and play that can be flaky. And the final one I put here is property-based testing, which is basically a way of you know how your code should behave. You know the kind of input it's supposed to have. But what you then do is you throw anything at it and see how it will respond. So you might want to read more about property-based testing, but that is just what it is at high level. It's basically a collection of it helps you set up your test in a way that you can flog your applications and see how it responds under pressure when you're sending it things that it shouldn't receive, or things when you're sending it inputs it does not expect. How would it respond and all those kind of things. So those are some of the key ones. So for Java, I listed a Java quick check, and then for .NET, for those who do the FS check. So with this is where I end my speech. Thank you very much for attending.